if the area of the right triangle ABC above base 24, and there is this relationship between lengths y and x, then what is the value of zit? This segment here. A right triangle is a triangle with a right angle. In the figure, the only vertex that could correspond to a right angle is clearly this on vertex A. And if this is the right angle, then the two legs of this triangle, that is segments AB with length x and segment AC with length y, could be the base and the height of the triangle respectively. If we consider that this is the base, then clearly this matches the requirement for a height, because it's a perpendicular segment drawn from the opposite vertex to the base. So the product of base times height over 2, that is the area of 24 units. But if we substitute here y in terms of x, we get x times x plus 2 equals 48. Yeah, this is a quadratic equation, we know that. But we don't need to solve a quadratic equation in order to pinpoint the value of x. Just think about two numbers that multiply together gives 48 and that their difference is 2. Obviously, the numbers have to be 6 and 8. There are no other two numbers that have this product and a difference of 2 units. And we're aiming only at positive values, right? In geometry, there is no meaning for negative lengths. So 6 and 8 are the values. X equals 6 and y must be 6 plus 2, so 8. But take a look. If you calculate the ratio of these two sides, AB over AC, you can see this 6 over 8. And this is the same as 3K over 4K, where K actually is 2. This proportionality constant reminds us that the two sides of this right triangle are proportional to numbers 3 and 4. There is a special triangle in which the legs follow such proportion, actually 3 to 4. So this side here must have a length proportional to 5. If K equals 2, that means that the length of BC must be 10. If we use the fact that the hypotenuse of this triangle is 10 units, then you could try to look at this figure under a different perspective. Imagine for a moment that you draw this triangle in an inverted way. You have here vertex C, vertex B, and vertex A here. And you have this segment which has length Z perpendicular to the side BC. So it's the same triangle, right? But if this is the base of the triangle, now wouldn't the segment Z be the height? Because it's a perpendicular segment drawn from the opposite vertex. So, because these can represent well the base and the height of this triangle, same as the base and the height could be the segments AB and AC, the two legs. Now the hypotenuse and the segment Z could be also base and height. So, if you multiply the length of the base by the length of the height, divide by 2, you also get the same area of the triangle, 24. From this, you get that Z must be 24 over 5. Option 2. Okay, so in most questions, you just need to match or recognize a common triangle, such as the triangle that has 3 sides proportional to the numbers 3, 4, and 5. If you recognize this one in the figure, okay, then you can use these proportions in order to solve the lengths of the segments that you still don't know. And then use other formulas such as the area and the concept of the area of a triangle, base times height over 2.